Science by Simulation, Volume 1, a Mezze of Mathematical Models by Andy French, published by World Scientific in 2022. This is a recipe book of mathematical models that can be enlivened by the transmutation of equations into computer code. There are 12 standalone chapters that are an eclectic mix of systems and stories rooted in common experience. It is not a textbook that might go out of date when your examination board next changes the syllabus. So the author is me, Dr. Andrew French, former radar engineer and physics teacher at Winchester College in the UK. Science by Simulation links to the Eclecticon educational website and a new computational physics challenge course run by the British Physics Olympiad. Now there are three ideas which underpin Science by Simulation. 1. Learn by practical experience to build mathematical models. Mathematics is the language of physics. 2. The power of context. Learn techniques because you have to understand a story, be it the epidemiology of Descartes' model of a rainbow, the atmosphere, strange, chaotic attractors of modelling, stock trading, or indeed elections. 3. Build computer simulations yourself. Make the bridge between reality and abstract problem solving, and develop creative skills that will make you useful as a scientist. So, introductory chapter. An example of an experimental analysis process via election cups. The time it takes a cup to sink varies as the inverse square as the diameter of the hole drilled in the base of the cup. And we can do lines of best fit and follow the data processing pipeline as a result. Snails of pursuit can only move at fixed speed but can change direction. A powerful gastropod pheromone causes them to chase each other. Their initial polygon arrangement will therefore rotate and contract until the snails meet in a writhing, slimy mess. This is an example of a mathematical modelling, and importantly, the importance of visualisation. Now, in 1665, the plague devastated the Derbyshire village of Eyam. The rector, William Mompesson, kept accurate parish records of those infected, susceptible, and those that had died. Plot and model these ISD curves with time, and you have the basis of the science of epidemiology. This is the largest chapter of Science by Simulation, and we apply the Eyam equations to Ebola and indeed in a certain restricted way to COVID-19. Bayesian inference, i.e. the probability of a hypothesis being true given observational data, is one of the most important ideas of science. The Bayesometer demonstrates how probabilities can be unexpectedly low if the hypothesis is rare and tests are not perfectly accurate. May's bifurcating bunnies model of rabbit populations is a classic gateway to chaos theory ideas. The maximum population fraction next year, x, depends on this year's population fraction. Depending on a growth parameter r, the asymptotic population either crashes, stabilizes, oscillates, or indeed becomes entirely chaotic. The double pendulum is an example of a mechanical system that can become chaotic. Conversely, Lorenz's system of weather predictions produces a strange attractor, a butterfly-shaped region of the parameter space, x, y, and z, that vary with time t, that all time histories appear to gravitate towards. A model of the atmosphere is developed, and temperature, pressure, boiling point, and lapse rate are predicted versus altitude for varying levels of humidity. Descartes' model of a rainbow, incorporating the subtle variation of the refractive index of water with the wavelength of light, allows us to predict the elevation of primary and double rainbows from the anti-solar direction of the sun. Organic-looking fractals of Benoit Mandelbrot are generated from very simple mathematical recipes involving complex numbers. In addition to the classic beetle-like picture, we can create light bulbs, rockets, plant and bacteria-like forms, and indeed Buddhist imagery. We'll have three concepts of radar: how to work out the signal-to-noise ratio with range, how to steer a beam of microwaves electronically via a phased array antenna, and how to improve range resolution by transmitting frequency-coded pulses. Starting with Eratosthenes and Al-Biruni's methods, we shall navigate the sphere and explore the ancient techniques of geodesy. How far is the horizon? How can we measure the radius of the Earth using weights, some string, and a protractor from the summit of a mountain? And indeed, how we can plot the Death Star. Can we make sense of money? We shall model mortgages, saving schemes, and virtually dabble in stock trading. And finally, in Power to the People, the concluding chapter, we shall analyse recent UK general elections. Were they fair? What could be the unintended consequence of a proportional system be? In fact, could we model the details of how it might work in practice? Science by Simulation is available to purchase from the World Scientific Online Bookstore. You can access it via my eccentric little website, www.eclecticon.info. Click on the Physics tab and follow the visual links. All the code for the course and many more resources can be downloaded from the Eclecticon. So, thank you for listening, and enjoy reading and ideally doing with Science by Simulation.